So Cambridge, exercise 2B, horizontal and vertical asymptotes. Now, I know that you have horizontal and vertical asymptotes when you're sketching normal hyperbolas. However, we're going to sketch something a little bit beyond normal hyperbolas today, okay? So just going to look at a few examples here, and our first one is going to be the following question. Question 2 in that exercise is to sketch the following. Y equals 2 over x minus 1 all squared. Now we're going to follow a series of steps to do this. Now the steps always are, if you're trying to sketch a curve, we want x-intercepts, y-intercepts, and things like that. But before we start, what do you notice about it? About the denominator? What can't it equal? What can a denominator not equal? Or what value of x are you not allowed to have? 1. So what I'm going to do first I'll just do my y-intercept. Let me just do my y-intercept. How do you do y-intercept? You sub x is 0. Let's just do that first. So step 1, we're going to find the y-intercept by substituting x is 0. So what do we get? Y is 2 over negative 1 squared, which is 2 on 1, which is 2. So the y-intercept of my curve is 2. Let's just have a look if we can do x-intercept. Oh, I'll do that. All right, I'll do x-intercepts. X-intercept. Sub y is 0. Yeah? 0 is 2 over x minus 1 squared. So, because we're going to follow these same steps. The first step is find any x or y intercepts. All right? How would you, what am I going to get here? Is this solvable? 2 over something is 0. Is the denominator allowed to be 0? That's actually got no solution. You know how I can cross multiply here? If I do 0 times that, don't I get that? 0 times that. You know, if I want to get that off the denominator, don't I times this by 0? And don't I get 0? That's got no solution. So there are actually no x-intercepts. No solution. 0 does not equal 2. Look, girls, 2 over something is 0. The only ever way that's going to be 0 is if the numerator is 0. If you're dividing two numbers and you get 0, the numerator has to be 0, not the denominator. So that's impossible. There's no solution to that. If I did want to solve, you cross multiply and you get 0 times x minus 1 squared is 2. That 0 times that is 0. So that's got no solution. You can't solve that. 2 divided by that is 0. It's impossible. If you've got a fraction that's 0, the numerator has to be 0. So there's no x-intercepts. Now, the next thing we're going to do is vertical asymptotes. Vertical asymptotes. Oh, sorry, 1m. So, vertical asymptotes are determined by what is on the denominator. So, because we know that x minus 1 squared cannot equal 0, are we good? That means that x, if I square root both sides, x minus 1 can't equal 0. That means that x cannot equal 1. So I've got one vertical asymptote. All right, so what do I know so far about my curve? That my y-intercept is 2 and that I've got a vertical asymptote that's x is 1. So always we find y-intercept, we find the x-intercept if we can. Step 2, always find vertical asymptotes by looking at the denominator. Looking at the denominator. What values of x are you not allowed to have? Then we're going to look at horizontal asymptotes. Now, I know you're probably going to think, why can't I just do a table of values? I could, but when we come to more difficult equations, we have to follow these steps. Okay, so we have to follow these steps. Always y-intercept, find the x-intercept if you can. Second, step 2, vertical asymptotes, by looking at the denominator. What values can the denominator not take on? Then we've got horizontal asymptotes. Now, that means all you do for here, as x gets big, as x approaches infinity, what does y approach? So as x approaches positive infinity, So as x approaches positive infinity, what does y become? Now there is all these algebraic ways of doing this, but you know what I just do? I substitute x as a big number and then I can tell. So as x gets big, what does y become? All you do, go to your original equation and sub x is 20 or something in it. And that's enough. Okay, so as x approaches positive infinity, y, we're going to see what y approaches. So what we'll just do, let's just say sub x is 20 or 10 or something. So here, if you sub x is 20, you get y is 2 over, so there's my equation, here's my equation. Y is 2 over x minus 1 squared. I might make this a bit bigger. So as x, if x was 20, wouldn't you get 2 over 19 squared? What's that? I need an answer. Is it small? It's tiny. It's 0.0 something. What do you get? So what do you think y is approaching? All right, what about if x was 10? Good, y is approaching 0. Let's say x was 10. What would you get for y? You would get 2 over 81, which is, someone worked that out as a decimal, 0.0 something, 2 divided by 81. So if x was 10, I'd get 2 over 9 squared, which is 2 over 81, which is 0.024, etc. Do you think y is approaching 0 as x gets large? Look, when x is 10, y is 0.024. When x is 20, y is 0.0055. I really think y is approaching 0. Y approaches 0 from above 0 or below 0? From above. So you put a little plus there, meaning from above. Do you see that, girls, or not? So by substituting, so girls, what I do, y-intercept first, vertical asymptotes by looking at the denominator. Next step is horizontal asymptotes. So this is what happens to the curve as you get very big x and very small x values. So first one, look, I often just do x is 10. You don't have to do 20. So when x is 10, y is 0.024, so it's just above 0. When x is 20, y is 0.0055, just above 0. Okay? So I would say that y approaches 0 from above, and as x approaches negative infinity, let's see what y approaches. Let's say you sub x is negative 10. What do you get for y? If you put x is negative 10 here, negative 10 minus 1 is negative 11 squared, that's 121. 2 over 121, isn't that going to be another small value? Because something squared is positive. Do you see what I'm doing, girls? I'm substituting. What do you get? 0.0165. Would you say y is approaching what? What's that getting close to? 0. From where? How do you know it's from above? Because it's positive. If I had negative 0.0165, it would be approaching 0, but from below. So 0 from above. Now look, this, I'm going to draw what I've got so far, all right? I know this is tricky, all right? All right, I'll move up. I'm going to start sketching what I've got. That the y-intercept is what? Good. So I come to my graph and I put a 2 here. 1, 2. That's my y-intercept. That's what I've got so far. What else do I know on my graph? Look up at the vertical asymptotes. What are the vertical asymptotes? X cannot equal 1. So I have a dotted line. Are we good so far? At x is 1. Now, I know, however, that as x gets really big, for example, when x is 10, y is 0.0, so it's above here. All right, so I know that the curve, and when x is 20, it got even closer. So I've got, that's my horizontal asymptote, like that. Right? What about when x was negative 10? What did I get? A positive number, very close to 0. So I'm here, somewhere here. Now we've got to see what happens to the curve. All right, we know that the curve, when x is -10, it's positive 0.0165. Don't put that value, just put that it's approaching 0. This is what I've got. And it cuts through 2. Now, and I've got that. I just don't know what's happening near 1. So all you do now is just substitute a value just below 1 and just above 1. Okay? So what we're going to do here, step 4 is the behavior near the vertical asymptotes. And I could have done this actually earlier. So I know I've got an asymptote, right, at x is 1. But I don't know if the curve is going to come down here or if it's going to go up there. By the looks of things, it's going to go up there. So what I'm going to sub next to x is 1, I know that when x is 1, it's undefined. So wouldn't I just do 1.1 and 0.9? A point just below 1 and a point just above 1. Substitute it into your equation. Now, sometimes you don't even need to substitute it. You can tell what's going to happen. Let's do the ones if I put 0.9 in. What's 0.9 minus 1? -0.1. Square it. Do you want to do it on your calc? Which would be positive 0.01. 2 divided by 100th. I think you're going to get 200. Have a go. So can you substitute 0.9? So girls, I know I've got an asymptote there. So all you do is you substitute a point before the asymptote and one after it. And then you'll know where the curve is next to that asymptote. You're just substituting in values. What do you get for 0.9? 2 divided by 0.9 minus 1 in brackets squared. Do you get 200? Is that what you're getting? Yeah. So we get 200. And here I'm thinking you're going to get 200 as well. Because 1.1 minus 1 is 0.1. 0.1 squared is 0.01. 2 divided by 100th is 200 again. Now, of course, you're not going to put that exact value in. All we know is that when x is almost 1, you get a very big value. Can you see that? And when x is almost, like when it's 1.1, which is just after 1, you're getting a very big value as well. And that's your curve. Probably a bit more symmetrical. Now, if you want, you can just choose another value. Let's just do when x is 2, what do we get? Just by substituting. 2, I think you get 2. I'm just going to put another point on the curve. When x is 2, what do you get? 2 minus 1 is 1. 1 squared is 1. You get 2, 2. And that's your curve. Now, you probably think, I could have just substituted values before. You could have, but this is leading us into much harder curves. Okay? Now, how did we know that this curve is always going to be above the x-axis? Why does it always have positive y values? Look at the formula. 2 is positive, isn't it? X minus 1 squared will always be positive. So a positive divided by a positive, that's why all your y values are above the x-axis. No matter what your x value is, your y value is always positive. Okay? I don't think this has got x-intercept anyway either. So let's just do y-intercept. Step 1 is to find the y-intercept by substituting x is 0. So we've got, this is our curve, y equals 3 over bracket, x plus 1 close bracket, x minus 3 is in another bracket. First step is always find the y-intercept by subbing x is 0. What do you get? 0 plus 1. Oh, yes, good girl. All right, if you want, you can start your sketch as soon as you start getting information, if you want, right? So what do I know so far? That my y-intercept is -1. That's what so if you want, you can start your sketch straight away. It might help you. Otherwise, you've got all this info and you're just going to get lost. Look, I'm not going to do x-intercept, just leave it, because I can already see when I put y is 0, 3 over that. I've got no y-intercept, so no x-intercepts. Don't worry about it. Step 2, let's do vertical asymptotes. So, you don't always have to do x-intercept. So y-intercept is the most important one. So y-intercept, let's do vertical asymptotes. How can you tell? This is by looking at the denominator. what values of x can you not have? So look at the denominator. So that x plus 1, that can't equal 0, and x minus 3 cannot equal 0. Neither of those can be 0. Or look, that times that can't equal 0, but each of them can't be 0. What can x not equal? X can't equal 1, x can't equal 3. So the actual vertical asymptotes are, so the way you write what the asymptotes are x is negative 1 and x is 3. They're the vertical asymptotes. All right? But I'm saying here that x can't equal 1 and x can't equal 3. That's what x can't equal. But the actual equations of the asymptotes are x is negative 1, x is positive 3. So I put dotted lines. Now, I'm going to do this slightly different order to what I did before because I think it makes a bit more sense to be a bit more systematic. See, once you've done those dotted lines, I think it makes more sense that I do my little table of values on either side of the dotted lines first. So what have we got? Y-intersect, plot it. I've got two vertical asymptotes. Now, I'm going to now do my little table. Instead of making this step 4, I'm going to just see what happens to the curve before and after each vertical asymptote. And I think what we should do is actually do our substituting now. It's much, much better. But it's got to be a point that's near 3 and a point near negative 1. Let's do the 3 first. What's something nice and close to 3? 2.9 and 3.1. So I know here I've got undefined. And here I've got undefined. What's a point a little bit less than negative 1? Negative 1.1 is less. Negative 0.9. Okay? Now, I want substitutions done in the formula. Now, don't look, this can take you a long time or it could be quick. I'm going to write the formula out again. Now, I wouldn't be putting it all in my calculator. You're going to spend forever doing that. So when x is negative 1.1, tell me what this bit is. What does this equal? You don't need to do negative 1.1 plus 1. You should know what it is. Negative 0.1 when you substitute negative 1.1, yeah? And negative 1.1 would be negative 4.3. All right, a negative times a negative is a positive. 3 over that. What are you getting? Actually, just work it out if you want. Yeah, I'm pretty sure. Oh, no, negative 4.1. Thank you. Thank you, girls. Yeah. Negative point. So 3 divided by, you don't need to put the 2 negatives in either. That's a waste of time because a negative times a negative is a positive. It's 3 divided by 0.41. What do you get? About 12. Oh, no, 7? I don't know. 3 divided by 0.1 times 4.1. Actually, do the substituting however you want. I don't care if you go 3 divided by bracket, negative 1.1 plus 1, close bracket, bracket, negative 1.1 minus 3, close bracket. But someone give me an answer. What do you get? And then work out the next one, and the next one, and the next one. Right. So I got 7.3. As you do this over and over again, you're going to realize you're either going to get a big positive value or a big negative value. So as you start doing this more and more and more, the actual value doesn't matter. You know that, for example, that's going to be positive because it was positive 3 over a negative times a negative gives me a positive. And then when you substitute the other one, what do you get for negative 0.9 when you substitute? So that was negative 1.1. What do you get when you substitute x is negative 0.9? Will this be positive or negative? Sorry, this bit. Negative 0.9 plus 1. Positive, that will be negative. You're going to get a big negative number because it's positive divided by a negative. What do you get? Negative what? Okay. So let's have a look here. So when x is just below, is that what you got? It doesn't matter exactly what you get. For this one, what did you get for this? Okay, I'll just go negative 7.7, and this must be 7.3. Negative 7.7. And when it's 3.1, girls, look, that will be positive, that will be positive. It's positive. So that's negative. This one will be positive. Positive what? It doesn't matter what it is. It's going to be big. Look, it's 3 divided. Yeah. Okay, this is what I've got. So I've got 7.3, negative 7.69, negative 7.7, positive 7.3. So all you do near your asymptotes is sketch. You don't put the value in. So when it's a little bit less than negative 1, don't you have a big positive value? So up here somewhere. Do you get it? When it's a bit less than negative 1, sorry, here. Yeah, a bit, sorry. That's negative 1.1. It's here somewhere. What about negative 0.9? Where is it? Up here or down here? Down. Negative 7. When x is negative 0.9, I've got negative 7, about down here somewhere. Oh, I know it cuts through negative 1. So I'm going to go like this. Right? It's got to go like that. All right. What about when it's 2.9? What do you get? Negative. So down here somewhere. Well, I'm hoping it just turns around. I'm hoping. All right. And what about when it's 3.1? What do you get? So I'm just plotting the bits I know. It goes up here. It's down here. Geez, it must just go like that. All right. Positive 7. So 3.1, where is the curve? Up here. No, up. 3.1 is positive. Look. 3.1, that's 4.1. Look, look. All you got to do, if you put, just looking, if that's 3.1, wouldn't that be positive? 3.1. Positive. Positive divided by positives is positive, and it's going to be big. It's always going to be big. So after a while, I wouldn't even be putting the value. I'd say it's going to be positive, it's going to be negative, it's going to be up here, or it's going to be down there. Now, I still haven't finished my picture. Look what we did with the other one. We also did something called, now what you might want to do in here, why don't you just do a few values, 1 and 2, for example, or just x is 1. What do you get when x is 1? Here's the equation. I get 3 over 2 times, what do you get? Negative 3/4 is a bit like that. And what do you get when x is 2? So that's x is 1. When x is 2, I get 3 there, and I get negative 1. So I get 3 over negative 3. Oh, I get negative 1. There we go. That's what happens. So it looks like it goes like this. And at this point here, I know it's painful, girls, is negative 1. What did you say? Negative 3/4. And by substituting, so I substituted there. Not negative 1. I got 1 negative 3/4, and here I got 2 negative 1. So girls, I wasn't sure. All I knew was that, yes, it approaches here, it cuts there, I know it's down here, let's work out what happens here. And these are nice numbers. I've got 1 and 2. So we just substituted x is 1 into the equation and x is 2 into the equation, and we found it went a bit higher and then it came back down. Now, I still don't know about these points. This is where I would substitute x, a big x, like something like x is 10, and x is negative 10, and we're done. So what am I doing through this whole thing? I'm just substituting. All I'm doing is substituting. First I do y-intercept by putting x is 0. Then I look at my vertical asymptotes, ladies, and then I look at a point on the left and the right of the vertical asymptote by substituting. After some time, I wouldn't be entering all these in my calculator. It's going to take you forever. You're just going to go, that would be positive, that would be positive, the whole thing's positive, it's up. Like it'll be up there or something. All right, now you need to do horizontal asymptotes. Horizontal asymptotes. So when x gets large. So I'm just going to go, when x is 10, what do you get? Y is, look at the equation. Wouldn't it be 3 over 11 times 7? See, girls, you don't put it in your calc. 3 over, if x is 10, you get 11 and 7. 11 times 7, 3 over 77. Well, that's 0 point something. What is it? Quicker than doing it on your calc.
0.048.
So what do you think? As x approaches positive infinity, y approaches 0 from above. Yeah? So I'm going to go to my graph in a minute, and I'm going to put that on. And then when x is negative 10, girls, when x is negative 10, I'm just going to look at it. It's going to be 3 over, what's negative 10 plus 1? That's negative 9. All right, I don't know what negative 9 times negative 13 is. So I'll just put that there. But girls, wait. Is it going to be a positive answer? So you're going to get, anyway, see what you get. What do you get? Which equals, it's going to be small too. 0.0 what? 256. So therefore, as x approaches negative infinity, big negative values, y is approaching 0, but from the positive value side. And then we're just going to draw that on and we're done. But you don't put those values in. You just show that it's approaching 0. So I'm going to go back up to my graph and fill the rest in. You'll be the substituting kings, queens, whatever. So as x when x is 10, in other words, as x gets bigger, y, so make that little statement at the end. As x approaches positive infinity, y approaches 0 from above. As x approaches negative infinity, y approaches 0 from above. So I'm now going to put it on my graph. Wait. I'll zoom out. And there's the graph. Can I see it? Not quite. There. So here, in other words, when x gets big, this is approaching 0. It's going to go like that. When x is like negative 10, it doesn't matter that I can't see negative 10. I just know that the value is getting very small and approaching 0, and my graph is done. See? I mean, you could start, you don't want to sit there working out other values. You'd be there forever. All right, so as x gets really big, negative, it is approaching 0, and that's the line. The x-axis is the line y is 0. This one for homework. But before I can tell where my asymptotes are, can you do something with the denominator? What can you do to it? Factorize it. It's a difference of 2 squares. Now, 4 is 2 squared, so it's 2 squared minus x squared. So how do you factorize that? Isn't a squared minus b squared a plus b, a minus b? You recognize it as that form. So that's 2 squared minus x squared, so that's 2 minus x, 2 plus x. Can you tell me what x cannot equal? So remember the steps. I'm not going to do it now, but the steps are y-intercept, you put x is 0. Come on, you can tell me. I know you can. X can't equal 2 and negative 2. Then you do those little tables and you substitute a value, 1.9, 2.1, negative 2.1, negative 1.9, and then you just do when x is 10 and when x is negative 10 and you're done. Got it? You know how with that last one I made you factorize the denominator? You can factorize both these. Let's factorize them both and see what we get. So can you think of 2 numbers that multiply to give 6 but add up to give 5? Yep, so it's definitely x plus 3, x plus 2 over. Can you think of 2 numbers that multiply to give a positive number but add up to give a negative? They must both be negatives. Negative what and negative? Yeah, so x minus 3, x minus 1. So this is that is our function. So look, it's a good idea to factorize the numerator as well in case we got some cancelling, but there's no cancelling. So let's start. Always, step 1, y-intercept, put x is 0. All right, I'm just looking. X is 0, x is 0, that's 6, x is 0, x is 0, that's 3. What's my y-intercept? Good. Y-intercept is 2. Do a quick sketch so that we know what we're doing. Next step is, so always, same steps every time. Don't worry about x-intercept. We don't always have them. Vertical asymptotes by looking at the denominator. Look at the factorized form of the denominator. X minus 3, x minus 1 can't equal 0. So what can x not equal? 3 or 1. So I've got 2 dotted lines. One at x is 1 and one at x is 3. So they're my Vertical asymptote. So this is what I know so far about my function. That it passes through 2, that I've got an asymptote at 1 and an asymptote at x is 3. Now, don't I just do my little tables, 1 for the point 1 and 1 for the point 3. Do you know what to do now? Don't you just substitute? Tell me which values you're going to substitute. Point, 1.1, 2.9, 3.1. These are undefined. That's undefined, undefined. Look, we can look at the equation and look, if I was looking at the equation, do not look at the unfactorized form. Look at the factorized form because you can actually tell what each section is going to be by looking at the factorized form. Otherwise, you're going to spend 5 minutes substituting. So what we're going to try and do here is not substitute. Now, 0.9. So when I do 0.9, tell me about the x plus 3 and the x plus 2. Isn't it going to be a positive times a positive over 0.9? What am I going to get? A negative and a 0.9 minus 1. It's negative. So it's a positive times a positive over a negative times a negative. It's a positive. Great. Now we're getting quicker. Right, what about 1.1? Positive, positive, negative, positive. 2 positives divided by a negative, negative. This is quicker now. All right, so we're starting to get better. So what's going to happen at 0.9, did I say positive? It's going to be up here. It will be big, girls. At 1.1, it's negative. It'll be down here. Look, if you're still not comfortable with that, you can try the values. What about 2.9? Have a look. Positive. 2.9 in here. Positive. 2.9. Negative. So I've got positive, positive, negative, positive. Negative, negative, so it's down here. So it'll be going like this. You can, as you're practicing, you can work it out, but you're going to start realizing next to the asymptotes, it's always big or small. And the vertical ones, that is. And 3.1, positive, 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 positive. It's all positive. Positive. Up here. Now, what would I do next? X is... I've still got to work out what happens in here, all right? Yep, definitely x is 2. Fantastic. So I'd definitely be putting 2 in. So when x is 2, yeah, what would I get? Y is, you just do it here, 5 times 4 over, I can see it, negative 1 times 1. Hey, that's negative. Whoa. Oh, all right. Yep. Well, these actually could be bigger than negative 20 then. They must be really big negatives. So you might just want to come back here to 1.1. That must be a very big negative. If that's negative 20, I've got 2 negative 20. So, you know, maybe a bit lower. I know it's not to scale. So what I need to do is draw this whole thing down lower. So maybe, so if you actually put, so 2 negative 20, get rid of that one. It's not low down enough. If you do 1.1, it's probably negative 50 or something. Do you know what I mean? And 2.9 might be negative 50 or negative 100. Okay, so I've got 2 negative 20. What's the last thing I need to do? X is, what's happening here? 10 and negative 10. And you're done. Okay, so off you go. So horizontal asymptotes, I'll set you homework. X is 10 and X is negative 10. You can go, I'll finish recording. So when X is 10, I get 13 times 12 over 7 times 9. I don't know, this is a bit of a weird one. This is 1 point something. And when X is negative 10, I get negative 7 times negative 8 over negative 13 times negative 11. We're looking at the horizontal asymptote. So we're up to here. When X is 2, we get Y is negative 20. So you don't need that bit there. Here, when you're looking at the horizontal asymptotes, just by substituting, when you substitute X is 10, you get 2.47. So I wouldn't say that that's really approaching anything. So you need to go for some larger values. And I tried x is 20 and I get 1.56, and still, look, that's really not, you can't tell what it's approaching. So I would actually jump straight to 100 and I'm getting 1.09. And you could also try x is 200, but I would say that this is definitely approaching 1. So as x approaches positive infinity, y approaches 1 from above. Now here as well, as x approaches negative infinity. So when x is negative 10, you get 0.39. I wouldn't say that that's close enough to 0 to think that it's approaching 0, for example. So look, when you look at, say, some of the other examples we did, like this one, so when I did when x is 10, I get 0.038. That's clearly approaching 0, and this one as well, clearly approaching 0. Numbers like 0.39, I wouldn't say is clearly approaching 0. So I tried at negative 100 and negative 200. Look, this appears to be approaching 0.96, 0.91, 0.96. That's getting closer and closer to 1, but it's approaching 1, but from below. So as x approaches positive infinity, y approaches 1 from above. So positive infinity. So we actually have a horizontal asymptote for this one at y is 1. And as x approaches positive infinity, y approaches 1 from above. So this is the horizontal asymptote y is 1. And as x approaches negative infinity, we're getting that y approaches 1 from above. Sorry, not from above, from below. So this is actually a really, really, really tricky one. So this is very tricky because look here. Now this is, like I said, very tricky. What happens is, and I know this is going to be a bit difficult for you to comprehend, but when x equals negative 10, you get 0.39, which is below the line. So it actually goes below and then it approaches the line. Now, I think this is probably a little bit beyond the scope of the extension of the mathematics course. Okay, this is more extension. So you might say, but how can you cut an asymptote, a horizontal asymptote? You're not allowed to ever cut vertical asymptotes, but with horizontal asymptotes, you can go below the asymptote. It actually only becomes an asymptote as x gets very small or as x gets very large. So with this particular one, it actually does go down and come back up. And it approaches 1, the line y equals 1 from below. So look, this one is very unusual, okay? Unusual for a 2-unit mathematics course, okay? It's more extension work. Actually sketch the graph here in Desmos for you to look at. If you look at your original curve, the unfactorized form is this: y equals x squared plus 5x plus 6 over x squared minus 4x plus 3. You can see we've got 2. I've actually drawn in the vertical asymptotes as well, okay? So, sorry, that's x is 1 and x is 3 is the other vertical asymptote. You can see here as x gets close, I can zoom it like that way. So you can see as x gets big, what happens. I'm actually going to sketch the line y equals 1 because we said that that was an asymptote as well, and that one I'll do in orange and I'll dot it as well. Okay, now you can see on this left hand side how the curve cuts through x is 2. Okay, then it drops actually down. Oh, so it's x is 0 somewhere here. But look, you don't really have to know where. Look, I think it's beyond the scope of the question. They will actually, if they want you to find that, they should ask what is the, we could go and find this by working out what the, actually there are 2 of them. You can see that it cuts, the x-intercept is -2 and -3. So, and then it comes back up. So the way so like I said, this is beyond the scope of the course unless they're specifically asking you. So it comes down and then it comes back up. So quite a tricky question, that one, all right? But as x gets quite small, it is approaching -1, because my asymptote here is y is 1. Sorry, it's approaching +1 from below the line. Look at those negative numbers. But here it actually cuts at -2, -3. And unless I expand, you can't tell. I will show you how to do that in a minute. Okay, and it cuts through y-intercept is 2 here. And there's your asymptote on the left-hand side of 1. And on your other side of 1, actually, we can see that -20 bit down here too. There's that 2, -20, and the rest of the graph. So quite a tricky curve, that one. Okay. Actually, it's showing negative something else. Actually, -20 isn't the turning point. So, okay. So like I said, very tricky. The turning point is somewhere else, but it's a point on the curve. Like I said, beyond the scope of what you're expected here. Okay, and that other section of the curve. So sorry, that was quite a tricky one. Okay. And if they want it in that much detail, they would be very specific, but this really is more of an extension question than a 2-unit maths question. Now, just showing that back on your sheet, it did cut through, sorry, it cut through -2 and back up through -3, okay? Now, I'm going to show you how you would work that out if you were asked to, and the rest of that you don't need, okay? So, they are the x-intercepts are -2 and -3. How do we find x-intercepts? We put y is 0. So, x-intercepts, put y is 0. Here is my equation. I have y equals x squared plus 5x plus 6 over x squared minus 4x plus 3. Now, if I put y is 0 here, so I'm just going to zoom in a bit. If I put y is 0, then that becomes 0. So I get 0 is x squared plus 5x plus 6 over x squared minus 4x plus 3. Now, the only way that that is going to be 0 is if the numerator is 0. The denominator is not allowed to be 0. So I can't say this over 0 is 0. So 0 must equal the numerator. So the numerator must equal 0. Okay? Now, I already know from before that if I factorize the numerator, I get x plus 3 times x plus 2. So therefore, my y-intercepts are... Sorry, my x-intercepts are -3, x is -3, and x is -2. So, right, remembering, for x-intercepts, put y is 0. So I put y is 0 here. The denominator can't equal 0, so the numerator has to be 0. It's got to be 0 over something. So the numerator is 0, I factorize it, and I get x is -3 and -2, and I put that on my graph, okay? So they're my x-intercepts, -3 and -2. So now I'm just going to redraw it, I think, in another colour because, okay, it passes through 2, it passes through, y is 2, x is -2, x is -3, and we know that 2, -20 is a point on the curve. And I know that it's actually not at the maximum, but don't worry about that too much, all right? Like I said, you're not expected to know it to that sort of detail. And that's what that curve looks like. I know that's extremely tricky, okay?